Okay, so today, for our last little topic that we're going to cover, okay, for preparation for the test, or that will be, game for the test, is going to be inverse trig functions. Okay. Now, this is not going to be some new graph that we're going to worry about, right? Okay, again, we've seen all the all 6 kind of graphs that we need to be concerned with, which we need to be concerned. Sine and cosine and tangent, cosecant, secant, and cotangent, those are going to be our graphs. Okay. But just like with every other, kind of new function that you learn, at some point you also learn about its inverse, how to kind of cancel it out, normally for the purposes of solving equations, right? We're not going to be solving trig equations in this unit. That will be next unit. So we're going to start out just kind of introducing the idea of inverse trig functions, and then we'll build upon it in a later unit, okay? I'm pretty sure just next unit, okay? So what is an inverse trig function? What does it look like, okay? So where we get the idea of an inverse trig function is if we have something like y equals the sine of x, okay? If you remember how we find inverses, right? To find the inverse of a function like this, what do we do with the x and the y? First step here. Find the inverse of a function. Switch them, right? You flip them, right? So we're going to flip-flop the x's and the y's. So we have now x is equal to the sine of y. And then we solve it for y. We get the y by itself. So to cancel out that sine, okay, what command or what function, what cancels out sine? It's sine inverse. So what we do is we then do sine inverse of both sides of the equation here. Okay, just like that. Okay. Now, the sine inverse of x, that doesn't simplify any further. We're kind of done with that. Sine inverse of sine, because sine inverse is defined basically to be the inverse of sine, they are supposed to cancel each other out and leave us with just y. And so y is the sine inverse of x, and that is the inverse function. Okay, that's how we denote it. That's how we show it. Okay, another way that you'll sometimes see this is also sometimes the arc sine of x. This is an alternative way to denote sine inverse. They mean the same thing. They're synonymous. Arc sine of x, sine inverse of x. Same thing. Okay? And that's why on your calculator then, if you ever wanted to evaluate, if we ever, well, we'll be using these later, okay, that's that button at the top there. Okay? Sine inverse. When you press second sine, that's sine inverse, that command that you have there. Okay? And again, we'll be using that in just a little bit. Okay, one thing I do want to hit, we'll talk about, and it'll come into more prominence next unit. The inverse sine function okay, is what we call that, like I said, and its domain, okay, well, the domain of sine, of inverse sine, the domain of inverse sine is the same thing as the range of sine, right? Sine and its inverse, arc sine or sine inverse, right? Those, they're related in that, like, if you remember, like, one way that we did this, right, we swapped x and y. X and y kind of swap. So the range of sine kind of becomes the domain of the inverse sine. So the domain will then be from -1 to 1. And then the range, well, now we're going to have some trouble, because the range, okay, the graph of sine, right, the graph of regular sine is a wave, and it fails the horizontal line test, which means that its inverse, sine inverse, will not be a function, unless we define the range in a specific way. So the range for sine, to keep it a function, is going to be -pi/2, less than or equal to y less than or equal to pi/2. Okay. And this then keeps that inverse sine function a function. Okay. And so that's our information there. So again, this will come more into play later. So right now, we'll just be using our calculators to evaluate any of these inverse trig functions. Okay. So, for example, let's say we have sine of theta equals 1/2. Okay, and we want to solve for theta. Okay. All right, so to solve for theta here, we got to get theta by itself. Right now, theta is not by itself, right? We have sine of theta. To cancel out sine, we'll use sine inverse. So I'll take sine inverse of both sides. Okay. I know it's very tempting, too, when you see sine next to theta like this. Sine is right next to theta. Normally when we see something next to a variable, that means it's being multiplied, right? So the temptation is, your mind is going to, some of your minds will see this as sine times theta, and you're going to want to try, you'll try and like divide. I've seen, and it happens every year, I see students trying to like divide both sides by sine here. But that's not what's happening here. It's sine of theta. Theta is inside of sine. So you have to cancel out that layer of sine. We cancel out the layer of sine by using sine inverse. Those will just then cancel. Just like we use natural log to cancel out e, we use e to cancel out natural log, right? We use a square to cancel out a square root, stuff like that, all right? We're using the inverses to cancel. And so we're left with then what sine of inverse of 1/2 is. And we want to evaluate that. Okay. So we press second sine, okay, on our calculators there, and we can just type in 1/2 like that as a fraction. And I get 0.52359877756. Of course, I'm in radian mode right now. Question?
How do I switch it back to rate?
Mode button. Okay, and you go down to degree. Yeah, alternatively, if you were in degree mode and you did that, you get 30 degrees. Okay, but we're going to keep things in radians for right now. Okay, so you get theta is approximately, because I have to round here, 0.524. Or we know exactly 30 degrees. I'll put that in parentheses. Okay. But of course, some of you guys, right, we know our unit circle here. When you're solving for theta, you're asking the question, sine of what gives us 1/2? Right, so remember back to your unit circle, sine of what angle gives you a positive 1/2? Well, it's going to be pi over 6. Yeah, and so that's why this is 0.524, which is exactly pi over 6. And so if you want, you can just give me pi over 6. That's fine too. Okay. Obviously I prefer pi over 6 because that's the precise answer. Okay. So we're essentially using our unit circle backwards. Rather than taking sine of an angle and giving us a ratio, we're figuring out sine of what angle gives us this ratio. Okay. Now there's one other angle on our unit circle that when we take the sine of it, we get 1/2. What's the other angle that when we take sine of it, we get positive 1/2? So think about in what other quadrant is sine positive? Yeah, Matt? 5 pi over 6. Very good. Exactly right. But why doesn't our calculator give us 5 pi over 6? It has to do with the range of inverse sine. 5 pi over 6 is outside of this range. Okay, 5 pi over 6 is outside of this range, and so we can't use the 5 pi over 6 as an answer there. Okay, won't work. Okay, so we use the answer, the value that's in that range, the pi over 6, 30 degrees. Okay. Again, that's not so much for you to worry about right now. We're going to be using our calculator for the majority of this, but just as, an example here. All right, let's try another one here. Let's do sine inverse. I'm just going to give you just a straight up, here's an inverse sine thing we're going to do. Okay, so no setup here with an equation. We're just going to solve. We're just going to get, what does this equal? So sine inverse of negative root 2 over 2. Okay, so again, we're going to type this into our calculator here. And again, radians is going to be the preferred measure unless the direction specified otherwise. Okay. Oops, negative root 2 over 2, Mr. Widmeyer. There we go. Okay. So it is negative 0.785, which is the same thing as negative pi over 4. And again, we're not so worried about that right now. We'll worry about the precise values more next unit. Okay. So again, you can think about inverse trig as like kind of the reverse of a normal trig function. So a normal trig function, you plug in an angle in radians or degrees. You plug in an angle. Your input is an angle. Your output is a ratio. Now, the input for an inverse trig function flip-flops those, right? Now the input is a ratio. Root 2 over 2, 1/2. Root 3 over 2, 0, 1. Those kind of numbers, right? It's one of the ratios. And then the output is going to be the angle that yields that ratio, okay? In radians or degrees again, whatever it might be. So when we go to evaluate something like the arc sine of 2, okay, so we go and type that into our calculator, second sine of 2, we get an error. Okay. So let's think about why that might be. Arc sine of 2. Why do we get an error? It says error domain. Well, one thing we can look at here is like the domain for arc sine is between -1 and 1, right? Another way we can think about this is, okay, this is going to equal some angle theta, right? Again, inverse trig, inverse sine, sine inverse of a ratio should give us an angle. We can use sine to cancel out arc sine. So we can take sine of both sides here. Sine of the arc sine of 2 equals sine of theta. The sine and the arc sine cancel, so we're left with 2 equals the sine of theta. And now we might have a better understanding, right, of why this thing doesn't work. Can sine of theta ever equal 2? No, right? It can't. What's the highest value that sine can be? When it's just normal sine, 1, right? So it can't get to 2. That's why it doesn't work here. Okay, so no solution, right? No solution. Bless you. All right, questions on any of that? We won't spend as much time with the other trig functions. I just want to kind of introduce the idea here, though, to you. And then we'll kind of move on from there. Okay? Cool. So then, of course, yes, we have some other inverse trig functions we're concerned ourselves with. We'll look at inverse cosine real quick, as well as inverse tangent. Okay? So for inverse cosine, or cosine inverse, the domain will also, again, be -1 to 1. Okay, -1 to 1 again. The range will be 0 to pi. Okay, and then for inverse tangent, excuse me, the domain will be -infinity to infinity, and the range will be -pi over 2 to pi over 2. Okay, like so. Alright, so you guys, I'll give you a couple here to try. Because again, it's just pushing buttons in your calculator. So find the arc cosine of 0. Find the arc cosine of root 3 over 2. And let's do the arc tangent. Actually, let's make it negative root 3 over 2. Sorry, so arc cosine of 0, arc cosine of negative root 3 over 2, please. And then arc tangent of negative 2.5. And again, you can give me exact values or decimal approximations. The first two you can potentially do without a calculator. The third one, you need a calculator for. Okay, you would need it. But the first two, you all have the knowledge to be able to do it without a calculator. Okay, so take like 2 seconds, type those in your calculator, just make sure you're getting this, able to type things in accurately. And again, let's give it in radians, please, radians. Bless you. So we should get answers like that. Okay, arc cosine of 0 is 1.5701. Arc cosine of negative root 3 over 2 is 2.618. And arc tangent of negative 2.5 is 1.190. Okay, arc cosine of 0 is also pi over 2, right? Because cosine of pi over 2 gives us 0, so then arc cosine of 0 would give us pi over 2. Okay. Arc cosine of negative root 3 over 2, 5 pi over 6 also is the equivalent measure there in radians. And then 1.190 for the arctan. There is no easy radian measure, there for that, because that's not a typical, tangent value. Okay. Questions on any of that? Again, right now you just need to be able to worry about, getting that typed into your calculator. Next unit, we will be evaluating these, kind of mentally without a calculator and stuff like that. That's what we're going to be working towards. Okay. All right. So, moving on from that. All right. So a little bit more here we're going to look at. We know, for example, that the arc cosine of the cosine of x is going to give us just x. So I'm off the screen there, right? We know that arc sine of the sine of x will give us just plain old x. And that tangent inverse of the tangent of x gives us just plain old x as well. And then the reverse is true as well. Whether you need to write this down. If cosine of the arc cosine of x is going to be just x, sine of the arc sine of x is just x, and tangent of tangent inverse of x will be just x. They undo each other, right? They're inverse functions. Okay. But what about something like, what if we mix them up though? For example, what if I take the tangent of the arc cosine of 2/3? now it's not so obvious, right? Tangent and arc cosine are not exact inverses of each other. Arc cosine is the inverse of cosine, and tangent, its inverse would be arc tangent, but they're not exactly related, right? They're not the same thing. They're not complete inverse of each other. So what can we do here? How can we work with this? Well, we'll work at this a piece at a time. So we'll start on the inside here, and let's think about, okay, what does arc cosine of 2/3 really mean? Well, remember that the arc cosine of something, that value that we're going to get, so if I were able to just like imagine taking the arc cosine of 2/3, I'm going to get an angle theta, right? 2/3 is a ratio. That's my input for an inverse trig. The output will be an angle. And then I'll take tangent of this angle here. So this thing, I'm just going to call this some angle theta. Okay? I know that the arc cosine of something is an angle, so I'm just going to call it an unknown angle theta. And I'll say then that theta is equal to the arc cosine of 2/3. So I'm just bringing in this variable theta to use here. And if this relationship is true, well, if I take cosine of both sides, I'll end up with cosine of theta equals 2/3. If I take cosine of both sides here, I have a cosine of theta equals 2/3. Okay. All right. Well, again, remember the cosine, right? It relates back to a right triangle here. So if I draw a right triangle, put my theta in there. Let's see. So according to SOHCAHTOA, a 2 would have to go here, and a 3 would have to go here. I could find the third missing side here by using Pythagorean theorem. So let's see here, it's going to be 2 squared plus b squared equals 3 squared. So I'm going to get b squared equals 5. So b equals the square root of 5. So this missing side here is the square root of 5. Okay. So again, where did this triangle come from? The triangle came from the relationship cosine theta equals 2/3. But where that relationship come from came from the fact that theta is arc cosine of 2/3. And that came back from here, the original problem. So when I said that arc cosine of 2/3 is the same thing as theta, I could rewrite this problem as the tangent of theta. Right? When I said, okay, let's just make this theta be equal to the arc cosine of 2/3. And that gave us this relationship here, and that gave us this relationship here. Well, now I just need to evaluate tangent of theta. What is tangent of theta? According to our right triangle here, what's the tangent of theta? What would it be? Root 5. Opposite over adjacent 2. Exactly right. Okay. Okay. And if you don't believe me, right, we can go to our calculator here. Tangent of the arc cosine of 2/3 gives us this nasty decimal. The square root of 5 divided by 2. Seemingly the same nasty decimal there. Okay? So there you go. Alright, let's try another one like that. So this is one kind of application of inverse trig here. Let's do the sine of the cosine inverse of 1/2. Okay. So this looks a little bit different than the one that I did before. Not only am I using different trig functions here, but instead of saying arc cosine, I'm just saying cosine. But the idea is still the same. Cosine inverse of a ratio, this is going to yield an angle theta. Right? This thing, cosine inverse of 1/2, is going to be some angle theta. And so I'll just say theta is cosine inverse of 1/2. Which means then that cosine of theta will equal 1/2. Okay, if we do cosine both sides there, we get cosine of theta is 1/2. And again, we get a right triangle. We can set up here. Okay, there's theta. Cosine is adjacent over hypotenuse. Okay, and let's see here, we're going to get 1 plus b squared equals 4, so we get b squared equals 3, and so b is the square root of 3. Okay, hey, it's a special right triangle. And so we have sine of theta. And the sine of theta will be opposite root 3 over hypotenuse 2. So there's the sine of the cosine inverse of 0.5, and then there's the square root of 3 over 2. Okay. So when you're taking one way to, kind of one way that this gets practiced, this inverse trig and stuff like that, or one way you're going to be able to do this is doing this kind of thing where you want to set up that relationship with the right triangle and use that to evaluate it. Okay. Okay. Obviously, a calculator would make this trivial, so this would probably show up on a non-calculator section because you could just otherwise just type it in. Right. So this kind of question would show up in a non-calculator section because you really don't need a calculator to do it. All right. Questions on any of that? I got one more thing I got to show you here. All right. And this is something back from like geometry, so hopefully it will be real quick. Okay. Sorry. One more thing you got to squeeze in, and that is solving for angles. Right. That's one other application. And this is where you guys probably first learned about inverse trig in geometry, and you maybe don't remember that, but inverse trig is also used to solve for angles in a right triangle. So for example, we want to solve for theta here. Okay. So, can we use Pythagorean theorem here? Can we use Pythagorean theorem here? We can. It's a right triangle. Okay, we've got two sides. We can use it to find the third side. Is Pythagorean theorem helpful? And yeah, answer is not really. It's not. Okay, because yes, maybe it would be helpful to have all three sides. We would have more options then about how we're going to solve for theta. Right now, we really only have one option to solve for theta, maybe two, but really just one. Okay. If you solve for that third side, then you would be able to use any trig function. But right now, we have the side opposite, the leg opposite the angle theta, and we have the hypotenuse. So what trig function can we use to relate these pieces of information that we have? Which trig function? Sine. From use sine. So we'll say that sine of this unknown angle theta is equal to the opposite over the hypotenuse. But of course, we're not interested in what sine of theta is equal to. We want to know what just theta is equal to. And so we're going to take sine inverse of both sides. Okay. So the sine inverse and sine cancel. We're left with just just theta. And so what is the sine inverse of 3/5? Well, that's not a typical ratio for us, so we'll just go to our calculator. Sine inverse of 3/5. That's the measure in radians. I feel like with triangles, though, it makes more sense to me to have it in degrees. So I'm going to switch it over to degree mode. And so sine inverse of 3/5 is about 36.870. I guess around that, too. Okay, and that is how you guys used it in geometry, right? That's where you guys first kind of talked about inverse trig functions and stuff, was just like that. And of course, you can do it. You can use it to evaluate, word problems too. A 40-foot ladder has to reach the top of a 35-foot tall wall. Okay. At what angle? must it be placed to reach the roof, or to reach the top of the wall? Okay, so there's the ground. Here's our wall. Maybe it's like the wall of a building. Okay, it's a really tall building though for 35 feet. Alright, and there's our ladder. And it's a 40-foot ladder, doesn't adjust. Okay, so at what angle must it be placed? So here's our angle. We'll put the angle theta right in there. Okay. Real life application, right? You guys, I'm sure anytime you have ever used a ladder, you thought about what angle you're replacing that ladder. Real life application here. Alright. So, what trig function are we going to use to relate these three pieces of information? Yeah, I'm not very creative here. Keeping it consistent. What is it? Sine. That's right. We got the opposite side, opposite leg, hypotenuse, so the sine of theta equals 35 over 40. Okay. And again, we're not interested in sine of theta, we want just theta. So we take sine inverse of both sides. So it's sine inverse of 35/40ths, which is approximately, and again, I'm going to say in degrees just because it makes more sense in word problems, I feel like this to be in degrees. 61.045. And our units are degrees, right? So we want to make sure to put that degree symbol there. Okay. So, that's the idea. All right. So obviously for a question like this, would be calculator active on your test, right? Because you really can't evaluate that without a calculator. All right. So the only inverse trig that would potentially be non-calculator, that will be non-calculator, would be these here, where you're evaluating the mixed up tangent of arc cosine, or sine of cosine inverse, that kind of stuff. That's the only one that would not be calculator active. Okay, and that's that. So, let me give you guys your assignment. Okay. Page 347. Numbers 5 through 15. 27 to 31. 55 to 59. 71 and 73, and all those are the odds. And there's one more, 106. So you do get an even one in there. Okay? So all these here are odd, but don't forget 106 there at the very end. Okay. And then I'll also pass out your review for the test, so you can start taking a look at that as well.